Hi there, this is Pranab from DPS Diary. So, in continuation to the session that I'm recording, so this is one of the chapters or one of the session that I wanted to cover. This is about clustered and non-clustered index, the primary key, clustering key and difference, and what is the common misconception that we have, and we will also cover unique key and foreign key. Okay, so let us start. So if you like my channel, then do subscribe and do comment. Okay, so what I have done is I have put the all these things which I am going to cover. So first we'll talk about what is primary key, then what is clustering key, clustered index, then non-clustered primary key. Okay, then how can you create clustered index on a table which is having primary key already, which is non-clustered. Okay, so we'll cover all that. So let's start. So first, to clarify, I think I have already covered one video wherein I have explained the difference in clustered and non-clustered index, and how can you have a primary key which could be clustered or it could even be non-clustered. Okay, now what is the difference in primary key and clustered index, which I ask generally in the interviews, and I have not got really satisfactory answer in last couple of months. Okay, so let me explain that one more time. So if you create primary key, by default it will be clustered index. Okay, so clustered comes into the picture when the data sorting is involved. So the physical sorting of data is something to do with the clustered index. Okay, so in Sybase, when you have clustered index, then the index ID will be 1, that is primary key, or only clustered index. But then you have to see what is the locking scheme of table. In the Sybase, it plays a major role. However, in case of MS SQL, the concept is different. There it's always 1 when you have clustered index, and when it is heap, then you will have 0. So there is difference in table and heap, you know that, you know about that. So in Sybase, it's not straightforward. So I mean, in MS SQL, the index ID of clustered index will always be 1. That is not the case in Sybase. It could be 1, but if it is only when it is all pages. If it is not all pages, then the index ID is something which varies, and then we will cover that through the lab. Okay, so first table I am going to create, that is the test underscore CL. So this is for the clustered index. Okay, so let us create this table. I have my lab here, so let me open the lab. Okay, I have a database already, so let me show you. Select db underscore name. So I'm into the user DB, and if you want to see the property of this, you can do sp underscore help DB and user DB. Okay, so it will give you all the information. What is the size of database? Okay, what's the log size and data size, right? And then what all segment we have. Okay, and which all options are enabled. So since we will be doing the alter table for locking scheme, so I have enabled select into bulk copy and parallel sort, because that is kind of must if you want to change the locking scheme. Okay, so let us copy the previous one to create the table. Okay, so this table is default. If you see, it is having ID column, which is int, and identity and primary key clustered. Okay, so here I am creating primary key which is clustered index. Okay, I am mentioning that. Now when I create this table, so you will see that table is created. Okay, now what we'll do, now we'll take the indexes and we'll see what all things is are there. So select star from sys indexes. Okay, where id is equal to object underscore id and test underscore cl, right? So let us see what all things we have. So here you see that we have one row which is for the, and index id is 1. Okay, so if you want to copy, so there is only one row, and this is the primary key of the table, and it is having index id as 1. Now as I talked about earlier, so this table is currently having all page locking scheme. Okay, so you see here the index id is 1. Okay, now what we'll do is, now we'll just go and create another table wherein I will have primary key, but it will not be clustered. I will specify it as non-clustered. So this is what is showing to you or helping you to understand how you can have a primary key which is not mandatorily clustered. You can define it and you can specify this as non-clustered. So let's create this table. Okay. So now you have another table which is test underscore NCL. Now if you want to check the indexes here, indexes where ID is equal to object underscore ID test underscore NCL. So here what you will see is how many rows you have. You have 2 rows there, okay, and then one is index ID 0 and other one is index ID 2. So and the locking scheme is still all pages, okay. So in the case of all page, let me show you one more thing here, test underscore NCL. So what you see, you will have a primary key which is non-clustered. You have a primary key which is non-clustered, okay, even though it's unique, but it's not clustered. So the data will not be sorted in this order. When you have a clustered key, then it will be sorted in that order, okay. Now how, and the locking scheme is all pages. So what we saw is the index ID 1 will not be used here, okay, rather it will be 2 because it is non-clustered, okay. Now what we'll do, next example, let's move with this. So when this all pages, now let us change this the previous one from all pages to data row, okay. So what we have seen previously when we saw the sys indexes where object ID we passed here and then you had only one row and this is nothing but 1. Now we'll change the locking scheme of the table to data row, okay, and then see what happens to the sys indexes. So alter table test clustered and let us change the locking scheme. So now it is changed. Now let us check the sys indexes what we have. What do you expect? Take a guess and let us see. So now you have 2 rows here, okay. So this 0 will come which is for the table itself, okay, and then you will have 2. So even though we have clustered index on this table, but due to the locking scheme change, now the index ID will change to 2. It was 1 before. Before we had index ID as 1 and there were only one entry in the sys indexes, right? Before it was only one index. If you see sys indexes, you had only one row and that was having index ID 1. So this is where there is a difference in MS SQL and Sybase. So in Sybase it depends on the locking scheme, not only on the index. I mean index ID is dependent on the locking scheme and clustered or non-clustered. So far it's clear. So you can have a clustered index table, okay. If it is all page, then index ID will be 1. If it is not all page, then it will take the next available index ID, okay, and then you will have extra entry that will be for the 0, which is for the table itself, okay. So far so clear, I guess. Okay, now what we'll do, so this one we checked. Now we will create a table, okay, which will have clustered index, okay, and then we will also create an index on this. So now in this example what I want to show is what we saw is the index ID became from 1 to 2 when you change the locking scheme. Now suppose I mean in this example test underscore CL we didn't have any non-clustered index, right? What happens if you have another index already available which is having index ID 2? So what will happen when you change the locking scheme? That is what I am going to show you now. So let us take this example. So here you have a clustered index table already with the index, okay. So you have primary key clustered. So now let's see this, select star from sys indexes where id is equal to object underscore id of test underscore cl underscore ind. So with the index, so it will have only one entry, right, as expected, which is having index id 1. Now if I change the locking scheme, this will become 0 and 2, the one that we saw. What if I create an index here on this table, okay, and then we'll check the index and then we'll change the locking scheme. So now you have table here, not on test underscore, we can do there also, but let's do it on this table, reset, okay. So create index, okay, mobile on test underscore cl underscore ind, okay, and mobile column. Okay, so now if we check the indexes, select star from sys indexes where id is equal to object underscore id and test underscore cl underscore ind. So you will have two entries here, right? One will be 1, which is for the primary key, and second one that we created now, which is primary, which is the mobile index, right? Now this table is still having all page locking scheme, right? You can check like this also, select lock scheme, okay, test underscore cl underscore ind. So this is all page. Now what we'll do, we'll change the locking scheme of this table, alter table test underscore cl underscore ind, okay, log data rows. Now what will happen? Now when you do that, so this will be like rebuilding the index, okay. Now let us, because you have a non-clustered index here, right? Now let us see what happens when you inquire from sys indexes table where id is equal to, okay, test underscore cl underscore ind. Now you have 3 rows. Now see, 0 has come and the one that we already had index id 2 of mobile index, that did not change. But the primary key, now it has taken index id of 3 because of locking scheme change. This is what I was telling earlier. So when you have all page locking, then it will have index id 1. However, when you change the locking scheme, then it will take the next available index id. It is not hard and fast what will be the number. If you have 10 indexes and the index id up to 10 is covered, so when you change locking scheme, then index id will change from 1 to 11. Okay, I hope this is clear. Now we'll see the next example. Okay, so this one I showed you. Now, okay, now let us take the example where I talked about when you have a table which is having primary key which is non-clustered, okay, which is having non-clustered primary key. So again we will check what all things we have here. So let us copy this. In case of any question, please feel free to comment and I will try to answer this, because this is something very basic stuff, but mostly people don't get it right. Okay, so if I start like going deeper a bit in this topic, people often gets confused. Okay, so let us see. Now this table is created. So here you have a primary key which is non-clustered. Okay, so as you know, if I run this sp underscore help test underscore and cl underscore prime, so what will happen is you will have non-clustered primary key. Okay, and index id, what will be the index id for this? You can guess that, right? It will not be 1, so you will have 2 entry. You can check that. Let us see. Indexes where id is equal to object underscore id. Instead of this, you can just pass the object id. Okay, so object id you can take from here, I think, or if you are not sure, what you can do, select star from sys objects. Okay, where I think we have covered this in the previous session. Okay, name is equal to test underscore ncl underscore prime, I think, right? Yes. Okay, so you will see the ID here, okay, name, and you will have ID, which is this is the ID. So select star from sys indexes where ID is equal to, and you can pass this number and you will see. Okay, so you have two rows here, right? So one you have 0 and one you have 2. Okay, 0 for the table, and since it is like non-clustered, so it will have index ID 2 by default. Okay, now what we'll do, okay, now we'll create one index on this. Okay, we'll create one non-clustered index on top of this. So you already have a primary key which is non-clustered, but then we'll create one more index. Okay, just to prove the previous point. So this is there, this is done. Now select star from sys indexes where ID is equal to, let's go with the previous one, it will be this one. Okay, so now you have 3 rows. Okay, so one is your table itself, second is the primary key cluster, and third is the one that we created now. Okay, on the column, which is location, I think. Yes, now this one is done. Now what we'll do, we'll create clustered index on this. So keep in mind, I have not changed the locking scheme. This will still have the locking scheme of all pages. Select lock scheme. Okay, test underscore NCL underscore prime, right? So this is still all pages. So I want to show how the how the index ID changes based on the type of index that you create. Okay, so now let's create the clustered index on this table. Okay, so when you create clustered index, all the non-clustered index will be rebuilt. Okay, because as I said, clustered index is something which talks about the physical sorting of data. So when you create it, so the data has to be sorted in order of clustered index or primary key if it is clustered. Okay, so now this is done. Now let us check the entry from the sys indexes. Now what will happen? Any guess? Now see, the rows have not changed. It is still 3 rows. The table that was there before, right, that is gone now, which was having 0 ID. So now the clustered index is there 1. Okay, now here clustered index is not on the primary key, it is different. Okay, so the cluster index is defined, but then it's not primary key. Primary key is something different, which is non-clustered. So you can still have a clustered index which is not primary key. Okay, so I'm just trying to explain you through all this. So, and this is the one that we created before. Okay, test underscore NCL. Now what we'll do? Okay, so this one I showed. Now let us change the locking scheme of this table from all pages to data rows. Okay, test underscore NCL underscore prime, I think, right? Yep. Okay, so all the indexes are rebuilt. Now let us check the entry in the sys indexes table. So now it became 4 rows, and the clustered index that was having one ID before, ID 1, now it has become 4 because that is the next number available. Okay, so I explained everything. So you have a table which is having primary key as clustered, then how the sys indexes will look like. Then you can have a table which is having primary key as a non-clustered, then how sys index will look like, and then how it changes when you change locking scheme of both the tables. So having clustered and non-clustered. Then I showed you having a non-clustered, you add an index, then you see how it is different in the sys indexes, and when you define a clustered index on top of the table which was having primary key non-clustered. So I hope this will clear your question and your doubt about clustered and non-clustered. Okay, so this is what was all about your clustered and non-clustered, and then so it's mainly about the sorting. It's mainly about the order of data on the disk. Okay, now let us talk about the primary key and foreign key. Let's create two tables. Okay, which will have the before that I wanted to show you one important stuff, which is so sp underscore help test underscore cl, right? So here you have a primary key which is clustered and locking scheme is data row, I think, and it is identity, I think, right? It is having identity column. Identity is 1. Okay, so in the sys indexes table, status 2 column is very important, and that will give you a lot of information. Okay, 3 status 2, yeah. So status 2 is very important. Here is 526. So depending, I mean, there is a table you can check on the info center side. Okay, so it is combination of what all things you have. Is it identity column? What is the locking scheme? Dependent on that, you have to add the number, and then that will give you this detail. Okay, so depending on the locking scheme, depending on the primary key, clustered, non-clustered, this will change. Okay, so this is very important. Now let us talk about foreign key, primary key and foreign key. Okay, so this is relatively straightforward, not that difficult as such. Let's create this table, department, and create a table. So this department table has got department number, okay, department name, and who is handling the department. Okay, so you cannot have a department which is not handled by anyone, right? So that is what I have given, and create table employee. So if anyone joins, so he will, anyone joins a company, so his entry will be made in the employee table, right? And then what we'll do, we'll create a constraint here in department. So which means that the manager who is there in the department table has to be there in employee table. You cannot have a employee, you cannot have a manager who is not an employee, right? So that is what, so it's pretty straightforward. So let us add this constraint on the manager table. Okay, so that is done, and now what we'll do, we'll just add few rows in the employee table. Okay, let us add this row. Okay, one row affected. Let's add one more row. Now I have added 10,001 and 10,002. Now I have to insert the data into department table. So now here I have to have manager value which should be already there in the employee table. If I insert something like this which is not there in employee table, okay, it should fail, right? You can see foreign key constraint violation. So this is what is about the foreign key. Okay, now if I make this entry, and then it should work because that row already exists in the employee table. So this is straightforward. Now let me show you. Now if you try to delete from the data, like delete from employee, okay, where if you give the employee number, right, emp number is equal to, if you try to delete this record which is 10,002, okay, so let us see what happens. Okay, you cannot delete it because this employee is the manager of a department. Okay, you can't delete, you can't even drop, right? So when you have too many foreign key constraints and all that, so this actually deteriorates the performance. So yes, it's important to have the referential constraint and integrity, but then it should be balanced. I have seen at one client's place wherein for one delete there were checking like 80 tables, 80 or 83, something like that. Okay, so that was slowing down like anything. And all the columns which is part of this, so if you have this manager column, right, so this manager should be indexed so that your search will become faster, the checking will become faster. Okay, so not only it's not only about delete, you can't even drop the table as long as this referential integrity is there. So if you want to drop the table, you should drop first the department table, okay, and then you can drop the employee table. Okay, there is no problem in that. So this is covered. Yeah, now let us talk about the unique index. Okay, so unique index is nothing but you have a index which you have defined as a unique. Okay, so let's create one table. The column you cannot make unique, you have to define a unique index. Okay, so table is created. Now let us define an index which is on the mobile number. Okay. Okay, now if you do sp underscore help and test underscore unique, okay, so what you will see is you have one primary key which is clustered and unique, and then you have non-clustered index which is unique. Okay, so this is something which enforces the uniqueness of data. Okay, now let us try to insert duplicate data and see what happens. Okay, first row is fine. Now if I try to insert the same row, it should fail, giving the error that you should have unique record for that column. Okay, now if I have to change something, so I need to change the mobile number. Anything else will work as it is, there is no problem, but this mobile number has to be different, and this will work. Okay, so I hope this will help you in understanding clustered index, non-clustered index, primary key, foreign key, and what is the common misconception, and then how the sys indexes system table and how the index ID changes depending on the locking scheme, depending on the type of index, is it clustered or non-clustered. Another thing is, in a table you can have only one clustered index, you can have multiple non-clustered index, you can have multiple unique index. Okay, so that is all for today. Okay, do let me know in case of any question. Okay, yeah, thank you very much. See you. Bye.